Hello everyone, good morning, good afternoon. Welcome to yet another informative webinar by Impetus. My name is Lisa Glenn, your host and presenter for today's session on building enterprise-ready, open for integration SaaS products. We're going to share with you a failure-proof way to develop enterprise SaaS solutions which can address the major integration challenges. Today we have Pankaj Misra, Senior SaaS Architect, and Ashish Kumar Dahiya from the Impetus R&D Labs as our expert speakers today. Pankaj and Ashish are our in-house SaaS experts at Impetus and provide high-end consultancy and R&D services to our enterprise customers. So let's go ahead and take a look at what today's session has in store for us. SaaS, or software as a service, is increasingly being adopted by the enterprises globally for their applications and business processes. In fact, Gartner is predicting that the enterprise SaaS application market to reach $10.7 billion in the current year while recording a 16% growth from 2010. However, the enterprises are discovering that the integration of SaaS applications is coming out as the biggest hurdle to the enterprise adoption of SaaS. Now, in this session, we will address the various integration challenges of an enterprise SaaS application. We will also discuss the design and architecture approaches to build integration-ready enterprise SaaS application. Further on, we're going to share the best practices in developing open for integration SaaS solutions. Now, before we delve into all the details of integration, I just want to quickly run you through the main characteristics of a SaaS application. We're going to go ahead and start with multi-tenancy, which can be achieved at various levels, starting from the simplest, which is at the infrastructure level, to the most complex at the application level. The second characteristic of a SaaS application is subscription and billing, which is a very critical feature, given that SaaS is a pay-as-you-go model. I believe that the need for flexible billing schemes is crucial to meet various license model requirements of end clients. Furthermore, every business would want a certain level of customization and configurability to meet their specific set of requirements. Now, given the nature of SaaS applications, the ability to scale quickly is critical, and so is its availability. Moving on to the next important factor, which is application and data security and privacy. And naturally, security is a multi-tenant, globally accessible system is very crucial and really is the key to acquiring and retaining clients in the long term. Now, having covered the important SaaS characteristics, let's understand the significance of integration to the successful enterprise adoption of SaaS apps. So the question is, why is integration so important? The integration among applications is required in the following two scenarios. First, when the customer or tenant wants to use its own user base to be able to access the application and does not want to share the user's information with any third party. Secondly, when the tenant wants his different applications to be able to communicate with others and bring all such applications under one umbrella. The level of configuration and customization defines how well the application can be altered in terms of the look and feel. It also helps determine whether the business processes are being followed in the application. However, when it comes to integration, it's altogether a different story. We will discuss the user integration and application integration in detail in these next few slides. But before that, I would just like to share with you the factors that affect integration and the most pertinent integration challenges that SaaS ISVs have to deal with. Now, out of the critical attributes of SaaS products that we discussed, there are some that directly affect the integration approaches and strategies. And the most important among them is multi-tenancy. The implementation approach for multi-tenancy would determine the integration strategy for a SaaS application. Since every tenant is isolated in a multi-tenant environment, the integration will need to address the tenant's specific needs. It will also have to ensure that the data and processing of every tenant is secure and isolated. The integration strategy also depends on the configuration support built into the SaaS application. Now, in order to facilitate the dynamics around the integration challenges, the application would need the required configuration support for better enablement of integration. Security is also a major consideration factor when we take into account the information exchange that happens across networks and systems due to various integrations. The nature of integration would be driven by the security considerations and compliance guidelines that should be addressed by the SaaS applications. The customization requirements and support also plays a major role in integration capabilities for SaaS application. Now, this typically includes integration capabilities driven by customizations, supported at the UI, services, and data levels. Now, you may wonder why this is important. Every organization has information distributed across various systems. When an organization is seeking a SaaS solution, they should ensure that their chosen solution has a flexible customization and configuration support. Doing so will enable the SaaS solutions to seamlessly integrate within the organization while delivering software as a service. But that's not all. Integration also impacts some of the other characteristics of a SaaS application, primarily in the areas of scalability and subscription. The integration of a SaaS application with external systems will impact the overall throughput and scalability of the system. Now, why? The answer is that now the SaaS application's performance and scalability will depend on the performance and scalability of these external systems. Furthermore, the cost of integration, as well as the cost of additional resources being consumed due to other integrations, will have to be factored into the subscription model of the SaaS application. We will now talk about the various integration challenges that ISVs might have to deal with for the enterprise adoption of SaaS apps. For a ready adoption of any SaaS solution, the most important factor is provisioning for a new tenant and its users seamlessly. This obviously has a big impact on the adoption of SaaS solutions. The more a SaaS solution is tuned into such capability, the better its ability to tap into more business. Any obstruction to this might affect the customer's acceptability of the SaaS solution. The enterprises use various systems in their ecosystem and may require an easier adoption of any new product or solution with their existing on-premise investments. The complexity in providing flexible endpoints in the SaaS product to be able to easily integrate with the on-premise systems may turn out to be a major challenge for any SaaS provider. The SaaS solution should be built on open standards with standard specifications to provision-ready and open for integration SaaS solutions. The other major challenge around integration is the secure exchange of information across systems and network. Any SaaS solution should be ready to meet the security standards. A well-planned SaaS implementation should be able to support a secure exchange of information. It should provide for the PKI infrastructure with its ability to encrypt or decrypt the sensitive parts of information at appropriate endpoints. Now, another critical challenge is the integration with disparate systems within the tenant's organization. This is one of the major challenges when it comes to the adoption of SaaS solutions in an enterprise. Now, let me explain. The tenant system may vary in terms of accessibility outside the enterprise network. However, a SaaS solution needs to facilitate such integrations by being able to provision flexible endpoints. Furthermore, they should also have the capability to exchange information with business processes and customizations that support white labeling of the user interface and services. And now we would like to know your opinion about the integration challenges. So we're going to ask you a question where you'll have the opportunity to respond. So the question is, what, according to you, are the major integration challenges in the enterprise adoption of SaaS? And your choices are the seamless integration with tenants' user base, integration with on-premise systems, provisioning of flexible endpoints, security, and the integration with disparate systems. You now actually have a total of 30 seconds to respond, so please go ahead and do so. Okay, it looks like we have the results, and apparently 37% have rated the integration with on-premise systems as their biggest challenge, while the second favorite is the seamless integration with tenants' user base. I'm going to now ask Ashish Dahiya, our expert from Impetus R&D Labs, for his take on this. Ashish, what do you think?
Thanks, Lisa, and hello to our webinar audience. Thank you for joining us in today's session. I do agree with our audience, Lisa, and their concern is quite valid. The enterprises works with various applications to carry out their business processes, some of which may have been developed in-house and some being purchased from third party and integrated to build a complete solution. The integration of such diverse application can be anybody's nightmare. And here, we are talking about integration with a completely new and an external system. And if the application is not open for integration, there is a great challenge ahead for the tenant and the provider.
Great, thanks so much, Ashish. We're going to go ahead and move on to the next section of our presentation now. Now, based on our experience with some of our clients, I'd like to share with you some architecture and design approaches that we have identified to build integration-ready enterprise SaaS applications. I want to start with the approaches for the user integration. We know that the most important entity in any application is its users. Every enterprise has its own set of users who would also be accessing the application. A SaaS-based solution should be able to provide the integration endpoints so that it can connect with the user base of the tenant. In fact, a loosely coupled design would enable easy integration. As you can see in this diagram, a SaaS product would require integration so that it can communicate with the user base of different tenants. Now, one of the ways of integrating the tenant user base with the SaaS product is through the Federated Identity Manager. In this case, the user identification, authentication, and authorization is federated to the tenant's user base, and the SaaS product behavior is based on the mapping between user roles and permissions. Ashish is going to go ahead and explain this a little bit further.
Sure, Lisa. As you can see in this diagram, when the tenant user tries to access the application, the access control module directs the authentication request to the authentication server, which in this case is an LDAP server. Storage of user roles for the tenants and user authentication by the LDAP server is based on the tenant's configurations. If the server is configured to use tenant's user base instead of its own, the application communicates with the tenant's authentication module, where a treaty is already in place. From there, the LDAP server gets the user authentication response, basis which it allows or disallows the application usage. The mapping of response to the application's own vocabulary will be performed at the application end via configurations. The LDAP server in the given scenario can be replaced with a set of services for user authentication, authorization, and user management.
Thanks, Ashish. Now we're going to go ahead and look at another scenario. Many a times, business users may need to access multiple systems to address a specific query. Since 2 or more applications are required in the process, it might get cumbersome to log into different applications and access the required data. The ability of a SaaS product to integrate with the tenant's authentication and authorization module and be able to provide a single sign-on will address such problems. Ashish, can you go ahead and explain how this works?
Certainly. As you can see in the diagram, when a particular user accesses the application, the access control module communicates with the configured tenant's SSO application. The application then allows users of the SaaS product without requiring the SaaS product to approach the tenant base directly. Here the access control module uses the tenant's authentication and authorization module via web-based SSO, which enables transparent user authentication for the SaaS product. The configurations at both the ends are required to enable seamless integration. In this case, if the users who were previously using the in-house application will no longer require logging into the SaaS product, that is via SSO.
Thanks, Ashish. Now, let's look at some of the architecture and design best practices for application integration. The integrated applications work in sync with each other and require generation of events at regular intervals. They will then communicate to the integrated applications at the other end about the different events in the system. These events allow taking appropriate actions to complete the process to merge 2 or more business scenarios. Now, let's say, for example, a client is using an in-house inventory management system and a SaaS-based order management system. The client wants to track the order server and update the inventory based on the available items. Let's take a scenario where there is a dispatch of a shipment. The order management application registers the event and sends it to the inventory management application. This event triggers a process in the inventory app to validate the quantity in the store, and if in case the inventory is below the minimum configured limit, it also places an order to update the inventory. Taking this example, let's discuss the types of event generation mechanisms. First, there's the push-based mechanism. Here, the inventory management application has exposed a service which would be invoked when the registered event is generated by the order management application. Next, there's the pull-based mechanism. Here, the order management application provides a service which returns the set of all events generated after the completion of a defined task. The integration via event generation allows for easy integration, as it provides a flexible means for event generation and consumption. The in-house applications can also make use of these events generated by the SaaS products to maintain audit logs. Now, the design and architecture of an application plays a major role in making SaaS product open for integrations. The loosely coupled nature of the product enables easier integration with other applications or systems. We believe that the loose coupling in the defined module is the key to flexible integration. As we know, the core principle behind the loose coupling is to reduce the assumptions that the 2 parties, which can be components, applications, services, programs, or users, make about each other when they exchange information. The more assumptions the 2 parties make about each other, the more efficient their communication is. However, as a downside, the less tolerant they will be of interruptions or changes because of their tight coupling. A great example of tight coupling in any application is its dependency on the different hardwired services. Invoking a service inside an application from another service is based on a lot of assumptions. The services have to know the nature of each other in terms of the expected outcome and the number of expected parameters. The service invocation in this case is very efficient in terms of performance, but inherits the tight coupling between the 2. Any change in requirements will adversely affect the 2 services. Though making assumptions might ease out the job to a great extent, but it limits the integration opportunities. We have seen that the interaction among the configurable parameters and appropriate adapters will provide flexibility and ease of integration. Now, following is the list of major integration scenarios for any enterprise-grade application. For example, data sharing, business process integration, and service-oriented architecture. Let's understand these a little bit better. First, we're going to go ahead and take up data sharing first. Now, we know that in an enterprise, one business process or a business entity is spread across various boundaries. So in order to complete a task, interaction is required among the multiple systems to process one client request. So what happens is that while processing a particular client request, these integrated systems generate and consume data. However, the individual generation and consumption of data can lead to a certain disconnect in the complete system, and this leads to the need of sharing data within different systems. Ashish is going to go ahead and explain this further. Ashish?
Sure, Lisa. We'll consider a scenario where the order management application requires customer information to make the shipment. Here, the customer details can either be managed by the application itself, or it can be retrieved from the available information from another application, which in this case is the customer management application. An integration configuration module provides mechanism to enable tenant-specific integration configurations. This module plays a key role in providing integration endpoints for both the applications.
Great. Let's now discuss the business process integration. Now, we've seen in the earlier slide that how two systems share the same data for completing a process. Similarly, the processing of a complex business scenario can be distributed over multiple systems, and in order to complete one business flow, there is a need to integrate these distributed processes. Ashish, can you explain this further?
Sure, Lisa. Let's consider the following scenario, where an automated bill management system makes the bill payments on a particular due date. The system makes use of an external payment management application and communicates it the required information, thereby ensuring that the system is making the payment. The external payment management system can be tenant's in-house application integrated with the SaaS-based automated bill management system. The payment system processes the request and returns the response token back to the bill management system, which finally generates the receipt for the user. The complete bill payment processing in this case is distributed over two different systems, which are integrated to complete the task based on the required business flow.
Thanks so much, Ashish. Now, as you have seen in the earlier slide, the shared business data and services, along with the distributed processing, is a desirable feature for integration. Any well-designed system which works on the loosely coupled services makes the work easier. Now, to discuss the service-oriented architectures. A service is a well-defined function that is universally available and responds to the requests from the service consumers. Once an enterprise assembles a collection of useful services, managing these becomes an important function. First of all, applications need some form of service directory or a centralized list of all available services. Second, each service needs to describe its interface in such a manner that an application can negotiate the communications contract with the service. Now, these two functions, service discovery and negotiation, are the key elements that make up a service-oriented architecture. Service-oriented architectures, or SOAs, blur the line between integration and distributed applications. A new application can be developed using the existing remote services that may be provided by other applications. Therefore, calling a service may be considered as the integration between the two applications. On the other hand, a service-oriented architecture usually provides tools that make calling an external service almost as simple as calling a local method, performance considerations aside. Because all services are available in a consistent manner, SOAs are sometimes referred to as the service bus architectures. The different connectors enable the mapping of services of an application with external services or application. The data transformation and mapping of the external data with internal structure will be provided in the tenant-specific connectors. We will now summarize the best practices that we've discussed in today's session. You can see the best practices of integration on your screen right now. Now, the base principle that you should follow during designing and architecting the application is to limit the number of assumptions for the system and prefer configurations. Though assumptions make the system more efficient, but the tight coupling in different business processes may adversely affect the integration strategies of the overall system. Internal integration points for a SaaS application translates to the integration points that the SaaS application natively or internally consumes. These integration points need to be designed for meeting the required performance, scalability, and SLA requirements. Now, on the other hand, the external integration points of a SaaS application translates to the integration of SaaS application with external on-premise or tenant system. In order to enable such integrations, the SaaS application should be built in such a manner that it dynamically provisions various endpoints for integrating with such systems. This integration may be via an ESB or via integration servers as part of the complete SaaS solution. Any enterprise would have standards-driven business processes and messaging. Now, in order to enable integration with such diverse systems, the usage of standard techniques and processes is very critical. We can use standard specifications like BPAL and JPDL for business integration. Now, at Impetus, we have compiled our learnings of building enterprise SaaS solutions and developed a SaaS maturity model that covers best practices for integration and other characteristics in a SaaS setup. The model helps to evaluate existing features and benefits that accrue from them and the gap that these might have from a possible ideal state situation. Pankaj, would you like to elaborate on that?
Sure, Lisa. Typically, the ISVs are increasingly keen to adopt SaaS business model and delivery platform. There are various motivation, delivery, recurring revenue model, etc. behind it. A SaaS maturity model provides an entire framework for quickly assessing the current level of maturity of a product offering. And it also provides a very objective outlook as to how to achieve a higher maturity levels by providing a concrete roadmap. The model defines 4 levels with increasing SaaS maturity, starting with the reactive model. The reactive model is easier to achieve, but it is least cost effective, and optimizing is the most mature in the hierarchy, as well as the most cost effective of all. Now let's have a broader look at the maturity model. As discussed, in terms of levels of our proposed maturity model, there are 4 levels that mark the increasing levels of sophistication of SaaS product offering. At the lower rung, a SaaS application may not be a pure SaaS application because it's not implementing multi-tenancy in its purest form. Here, we are also being reactive to each new customer we acquire. This is the base level. The next level is managed, in which we start seeing some elements of multi-tenancy, at least at an infrastructure level. This level provides co-screen support for metering and billing and the application usage with support for basic level of tenant-specific branding for the application. Now, as we move towards the more adaptive and optimizing levels, we see more sophisticated implementations of multi-tenancy as well as the other elements associated with SaaS application. The maturity of a SaaS product defines also the levels of integration from an integration perspective, which defines various opportunities for external applications or systems for integration. The reactive model presents no or limited opportunities for integration as multi-tenancy is instrumented in a controlled manner. As we move towards optimizing model, the design and architecture of the application is based on configurations rather than assumptions and exposes flexible integration endpoints. Any SaaS application can be calibrated using SaaS maturity model with appropriate weightage assigned to various factors based on the specific business domain of the SaaS application. For example, the SaaS application handling sensitive customer information may prefer to assign more weightage to security than to other factors like multi-tenancy. So, while the application is more mature application, it might prefer to keep a complete isolation of process and data, resulting into lower maturity levels for multi-tenancy but higher maturity levels for factors like security.
Great, thanks Pankaj. I would now like to share with you the Impetus approach to building SaaS solutions. iSaaS is Impetus' capability to provide SaaS-enabled solutions not only for new applications, but also for modifying existing application to a SaaS model. As seen here, iSaaS platform provides various capabilities out of the box. The main driving factor being multi-tenancy. The other capabilities revolve around other much required features from building and managing SaaS applications. It provides two flavors of building SaaS-enabling application. One way is an automated, or rather we can call it the instrumentation way of SaaS-enabling existing applications, while the other is used via iSaaS SDK API for either building a new SaaS application or converting an existing application to SaaS model. The instrumentation or automated approach is a non-intrusive approach that can provide a quick conversion of existing small and independent Java applications to a SaaS model. iSaaS SDK API provides a more fine-grained control on SaaS enabling or creating a new SaaS application from scratch. Now, the iSaaS SDK API is comprised of marker interfaces that helps developers to achieve various aspects of SaaS application with minimum effort, enabling them to concentrate on the business domain implementation rather than SaaS challenges. It provides inherent support for multi-tenancy, subscription, white labeling, user provisioning, and reporting capabilities from SaaS metering perspective. Now, this platform provides SaaS enablement for Java-based applications with support on all major application servers, frameworks, and database servers. Now, it looks like we've already started receiving some of the questions from our audience, and I would like to remind you that you can send in questions using the chat window. But before we move on to the questions, I would just like to introduce Impetus Technologies to our audience. We offer end-to-end services in SaaS development or enablement. We leverage our best practices to address ISVs and technology companies' pain points while enabling SaaS. With ongoing investments in research and application of emerging technology areas, innovative business models, and an agile approach, we partner with our client base comprising large-scale ISVs and technology innovators to deliver cutting-edge software products. Our expertise spans the domains of data analytics, large data management, SaaS, cloud computing, mobility solutions, testing, performance engineering, and social media, among others. Okay, it looks like we're now going to take up those audience questions. And it looks like the first question we have is, what is the impact of SaaS integration on the security? So what do you think?
Sure, Lisa. So when we talk about security, there are various levels at which we possibly will need to ensure security while integrated various networks and systems together. Since the information that may be getting exchanged could be a sensitive information, it is imperative to look at the security from transmission perspective, from endpoint perspective, and from data perspective. So from transmission perspective, some of the options that are available is possibly making use of secure socket layer or making use of web services based security specification, or otherwise by use of public key or private key infrastructure. When we talk about endpoint security, there are various ways by which the endpoint security can be ensured. One of the most popular and widely used practices by use of token-based authentication and access mechanism. Even an open auth mechanism would further enable more of open standards in getting built into endpoint security. In terms of data security, the encryption is always an option, and based upon the length of the data and to the extent the data needs to be secured, proper encryption algorithms can be employed in order to ensure security of specific pieces of information.
Okay, great answer. Looks like we've got our second question, and it asks, what do you mean by prefer configurations over assumptions?
While assumptions may enable quick integration solution, configurability will provide the much needed flexibility in integrating systems across tenants. So here basically the assumptions will enable us to achieve the integration from a hardwired integration with specific systems. The configurability will enable the application to be extremely adaptable across the tenant organization systems.
Okay, great question. Another question for you. Is it always mandatory to build system based on configuration? What do you think?
It's not mandatory. It depends upon the integration scenario. So if we are having internal integration points, there the preference is to go with more optimized and scalable options for integration, wherein we could possibly go with some of the closed standards in order to achieve the required scalability and integration and adhere to various SLA requirements. But when we talk about specific external integration points, we do have to consider a configurable and flexible integration option so that we can enable the SaaS application to seamlessly integrate with tenants' systems.
Okay, great. It looks like there are a few more questions that we have received, but due to the time constraints, we will be addressing those questions by email a little bit later if you asked a question that we did not address. Okay, I just want to thank everybody for joining us today. We really hope that this discussion was a learning experience for everyone and will add value to your enterprise SaaS initiatives. If you have any questions, please feel free to email us at inquiry@impetus.com, or you can visit our website at www.impetus.com. We also would like to inform you that you can meet us at the Cloud Computing Expo in New York City from June 6th through 9th. And Vineet Tyagi, who is our Senior Director of the R&D here at Impetus Labs, will address a session on secrets of building a cloud vendor agnostic petabyte scale application at the Expo on June 7th. And as promised, we will soon send you the registration details for your free Gold Pass worth $1,700 for the Cloud Computing Expo in New York City. Once again, thank you so much for joining us in this session today. Goodbye.